The requirements for NM wire, also known as non-metallic sheath cable, in unfinished basements can vary based on location and the specific electrical codes adopted by that jurisdiction. Let's explore the requirements for Ottawa Lake, Michigan, and contrast them with the possible requirements in Toledo, Ohio, to clarify when NM wire must be installed in conduit. In Ottawa Lake, Michigan, the governing code is the 2023 Michigan Electrical Code, which is based on the 2020 National Electrical Code, or NEC. According to this code, NM wire is permitted to be exposed in unfinished basements, provided that it is securely supported and protected from physical damage. However, there are specific circumstances under which NM wire must be installed in conduit or another approved raceway. These include when the NM wire is run on the surface of walls, ceilings, or floor joists, where it may be subject to physical damage. Additionally, if the NM wire is installed in a wet or damp location within the unfinished basement, it must also be protected by conduit. Now, let's consider Toledo, Ohio, where the electrical code requirements may differ. According to the 2020 NEC, NM wire in unfinished basements in Toledo must be installed in conduit if it is not located within 8 feet above the floor or within 6 inches of the joists. This means that if the NM wire is running along the walls or ceiling at a height less than 8 feet from the floor, or if it is closer than 6 inches to the joists, it must be enclosed in conduit to provide physical protection. In summary, for Ottawa Lake, Michigan, based on the 2023 Michigan Electrical Code, NM wire can be exposed in unfinished basements as long as it is securely supported and protected from physical damage. However, it must be installed in conduit if it is surface-mounted or located in wet locations. For Toledo, Ohio, the 2020 NEC requires NM wire to be installed in conduit in unfinished basements if it is not within 8 feet above the floor or within 6 inches of the joists. This requirement applies specifically to situations where the wire is exposed and potentially prone to physical damage. It is important to know that local amendments to the NEC can further modify these requirements, so it is always best to consult with a local electrical inspector or a licensed electrician to ensure compliance with the specific regulations in your area. When working with electrical wiring in unfinished basements, several key considerations can help ensure safety and code compliance. Firstly, always prioritize safety by disconnecting a power supply to the circuit before beginning any wiring work. Use appropriate personal protective equipment, including safety glasses and gloves, to protect yourself from potential hazards. Secondly, carefully inspect the existing wiring to identify any signs of damage such as frayed insulation, exposed conductors, or corroded connections. Replace any damaged wiring to ensure the integrity and safety of the electrical system. Thirdly, when installing NM wire, securely support it at intervals specified by the electrical code. This typically involves using cable staples or clamps to attach the wire to framing members, such as joists or studs, at intervals of no more than 4.5 feet. Ensure that the supports do not damage the insulation of the wire. Fourthly, when running NM wire through holes in framing members, protect the wire from abrasion by using bushings or grommets. These devices provide a smooth surface that prevents the wire from rubbing against the edges of the hole, which can cause damage to the insulation over time. Fifthly, in areas where NM wire is subject to physical damage, such as along the surface of walls or ceilings, install it in conduit or another approved raceway. This provides a protective barrier that shields the wire from impacts and other potential hazards. Sixthly, when working in damp or wet locations, use appropriate wiring methods and materials that are specifically designed for use in those environments. This may include using moisture-resistant NM wire or installing the wiring in watertight conduit. Seventhly, properly ground all electrical boxes and equipment to provide a safe path for fault current to flow back to the source. This helps to prevent electrical shock hazards and ensures the proper operation of overcurrent protection devices, such as circuit breakers or fuses. Eighthly, label all circuits and wiring to clearly identify their purpose and destination. This helps to prevent confusion and makes it easier to troubleshoot electrical problems in the future. Ninthly, after completing the wiring work, thoroughly test the circuits to ensure that they are functioning properly and that there are no faults or shorts. Use a multimeter or circuit tester to verify the voltage, current, and continuity of the wiring. Tenthly, keep a detailed record of all wiring work, including the location of circuits, the type of wiring used, and any modifications that were made. This record can be valuable for future maintenance and troubleshooting. In addition to these practical considerations, it is also important to understand the relevant sections of the National Electrical Code, or NEC, which provides detailed requirements for electrical wiring in various locations and applications. For example, NEC Section 334.10 addresses the uses permitted for an M cable, while NEC Section 334.12 covers the uses not permitted. NEC Section 334.15 specifies the requirements for supporting an M cable, and NEC Section 334.17 outlines the rules for protecting an M cable from physical damage. Furthermore, understanding the concepts of ampacity and voltage drop is crucial for ensuring the safe and efficient operation of electrical circuits. Ampacity refers to the maximum current that a conductor can carry continuously without exceeding its temperature rating, while voltage drop refers to the decrease in voltage along the length of a conductor due to its resistance. It is important to select conductors with adequate ampacity to handle the expected load and to minimize voltage drop to ensure that equipment operates properly. When calculating ampacity, consider the ambient temperature, the number of current-carrying conductors in a raceway or cable, and any directing factors that may apply. Use the appropriate tables and formulas in the NEC to determine the correct conductor size for the application. Similarly, when calculating voltage drop, consider the length of the conductor, the current flowing through it, and the conductor's resistance per unit length. Use the voltage drop formulas in the NEC to ensure that the voltage at the load is within acceptable limits. In addition to these technical considerations, it is also important to be aware of the administrative requirements for electrical work in your jurisdiction. This may include obtaining permits, scheduling inspections, and complying with local building codes and regulations. Contact your local building department or electrical inspector to determine the specific requirements for your project. Finally, remember that electrical work can be dangerous, and it is always best to hire a qualified and licensed electrician if you are not comfortable performing the work yourself. A licensed electrician has the training, experience, and knowledge necessary to safely and correctly install electrical wiring in accordance with the applicable codes and standards. Furthermore, hiring a licensed electrician can help to ensure that your electrical system is properly designed, installed, and maintained, which can save you time, money, and headaches in the long run. To delve deeper into the specifics of electrical wiring in unfinished basements, consider the following points. Firstly, the definition of an unfinished basement can vary slightly depending on the local jurisdiction and the specific interpretation of the electrical code. Generally, an unfinished basement is considered to be a basement that is not fully finished or converted into habitable space. This typically means that the basement has exposed concrete floors and walls, unfinished ceilings, and limited or no insulation. Secondly, the requirements for protecting an M cable from physical damage in unfinished basements are often based on the likelihood of the cable being damaged by impacts, abrasion, or other hazards. This is why the code typically requires an M cable to be installed in conduit or other raceways when it is run along the surface of walls, ceilings, or floor joists, where it is more likely to be damaged. Thirdly, the 8-foot height requirement for an M cable in unfinished basements is intended to provide a reasonable level of protection from physical damage, while still allowing for some flexibility in wiring methods. The intent is to keep the cable out of reach of most people and objects that could potentially damage it. Fourthly, the 6-inch distance requirement from joists for an M cable in unfinished basements is intended to prevent the cable from being damaged by objects stored or moved in the joist space. The idea is to keep the cable far enough away from the joist so that it is less likely to be accidentally hit or snagged. Fifthly, the requirements for wiring in damp or wet locations in unfinished basements are intended to prevent electrical shock hazards and to protect the wiring from corrosion and deterioration. This is why the code typically requires the use of moisture-resistant wiring methods and materials in these locations. Sixthly, when installing conduit in unfinished basements, be sure to use the appropriate type of conduit for the application. For example, rigid metal conduit, or RMC, and intermediate metal conduit, or IMC, are commonly used for providing physical protection to wiring in damp or wet locations, while electrical metallic tubing, or IMT, is often used for general-purpose wiring in dry locations. Seventhly, when grounding electrical boxes and equipment in unfinished basements, be sure to use the correct grounding methods and materials. This typically involves connecting the metal enclosure of the box or equipment to the grounding electrode system of the building, using a grounding conductor of the appropriate size. Eighthly, when labeling circuits and wiring in unfinished basements, be sure to use durable and legible labels that are resistant to moisture and fading. This will help to ensure that the labels remain readable over time, even in harsh environments. Ninthly, when testing circuits in unfinished basements, be sure to use a calibrated and reliable testing instrument. This will help to ensure that the test results are accurate and that any faults or shorts are detected. Tenthly, when keeping records of wiring work in unfinished basements, be sure to include all relevant information, such as the date of the work, the name of the electrician who performed the work, and a detailed description of the wiring methods and materials used. This information can be valuable for future maintenance and troubleshooting. In conclusion, understanding the requirements for an M cable in unfinished basements is essential for ensuring the safety and compliance of electrical wiring installations. By following the guidelines and best practices outlined in this discussion, you can help to prevent electrical hazards and to protect your property and occupants from harm. Remember to always consult with a qualified electrician or electrical inspector if you have any questions or concerns about electrical wiring in unfinished basement.